Hello everyone, and welcome to our 11.3 Part 2 lesson on area of trapezoids, rhombuses, and kites. And so the first thing we're going to do is get started with the formulas. And so the area of a trapezoid formula is very similar to the area of a triangle, except that remember, for a trapezoid, instead of just having one base, you're going to have two bases. So we know that we've got base 1, base 2, and I have a height between those two bases. And so instead of it being base times height divided by 2, like for a triangle, it's going to be very, very similar. It is going to be your base 1 plus your base 2 times your height divided by 2. Okay, so you're going to add your bases together, multiply it by your height, and that will be divided by 2 to give you your area of that trapezoid. Okay, what is it for a rhombus? For a rhombus, remember, a rhombus is going to be a four-sided figure where all four sides are the same. In that four-sided figure, you have two diagonals. You have something, you've got diagonal 1 and diagonal 2, and they're not necessarily the same length. And so what you're going to do for the area is you're going to multiply those diagonals times each other. You're going to find the product of the diagonals, and you're going to divide by 2. So D1 times D2 divided by 2, and it's actually the exact same for a kite. We know that in a kite, I have two diagonals of different length. And so we know that those are perpendicular to each other. So we have diagonal 1 and diagonal 2, where one is longer than the other one. And so that's going to be the exact same formula as the rhombus. So D1 times D2, that's the product of those two, divided by 2. And so really, even though this is about 3 different shapes, we only have 2 different formulas. Okay, so the directions say solve for the indicated values, round to the nearest tenth if necessary. So the first one it tells you is a trapezoid. So since it's a trapezoid, let's start with that formula. It's going to be very similar to a triangle, base 1 plus base 2 times your height divided by 2. So let's go through and highlight those things. Our bases are always going to be the parallel sides. Our height is going to be that distance, that straight up and down distance between it, so you're going to look for that right angle. So let's just go ahead and plug in those values. My area of this shape is going to be base 1, we'll just call that 16. You can name them, because we're adding, it doesn't matter which one is base 1, which one is base 2. We're going to add 16 and 9 together. We're going to multiply that by 10, and then we're going to divide that by 2. So 16 plus 9 is going to give me 25. That times 10 is 250. Divided by 2 is going to give me an area of 125 feet squared. Remember that area is always in units squared. So that's how much space is on the inside of this trapezoid. Again, they give us another trapezoid next. Let's go ahead and write our formula. That is going to be area equals exact same formula, base 1 plus base 2 times my height divided by 2. So I'm going to go ahead and color code just like I did before. Here are my bases, 9 and 22. Here is my height. The vertical distance between them, I know that because that's a right angle. And then I'm just going to plug in those numbers. So area is going to be equal to 9 plus 22. Those are my bases, added together, times my height of 7.5 divided by 2. So 9 plus 22 gives me 31. That times 7.5 gives me 232.2. And then that divided by 2 is going to give me, it's exactly 116.25, but it says to round it, so we're going to round that to the nearest tenth. 116.3 meters squared would be my rounded area. So this is my exact area, and this is the approximated or rounded area. That's how much space is on the inside of that triangle. So just a little bit less space than the previous, the previous trapezoid. Just a little bit less space than the previous trapezoid on this trapezoid problem. Okay? All right, now on this problem, I do like this problem a lot because it gives you extra things. So it makes you focus on what you need. We need our bases, which are the parallel sides. Notice that that is an 8 and a 2. So together, I know when I put those together, 8 plus 2 is going to give me a base of 10 inches. And then what is my height between those two? My height between those two is going to be the vertical distance between those two bases, even though it's turned sideways, is going to be this piece. And so I'm going to have to find that height because I don't currently have it. So in order to find that height, I'm going to use some Pythagorean theorem. I know that since this is a right triangle, I can do 2 squared plus h squared, and that should be equal to 6 squared. So h is going to be equal to 6 squared minus 2 squared. That is going to give me h squared equals 32. So h is going to be equal to the square root of 32. And we're going to leave that as the square root of 32 because we want it to be exact. We're not going to round until the very, very end. Square root of 32. Okay, so whenever I plug this into my formula now, area is going to be equal to base 1 plus base 2, so that's going to be 7 plus 10, times my height, which is the square root of 32, divided by 2. Okay, so I'm going to do 7 plus 10 gives me 17, times the square root of 32 gives me 96.16, and it keeps going. I'm going to divide that by 2, and I'll round at the very, very, very end. So that is going to round to approximately 48.1 inches squared of area, and I didn't round it until the very end. Okay? They give me a few more trapezoid problems, but where we don't necessarily immediately have all the information that I need. So I'm going to zoom into this picture. Remember that we need our bases, so we do have our bases. Let's highlight those in yellow. There's 5, there's 7. What is the height? Well, I don't know the height. There's my right angle, but that height is also going to exist right here. So I'm going to go ahead and draw that in. I know that the height lives right here. And this creates a 30, 60, 90 triangle. And I don't have any of the pieces currently, but I know that the 5 and the 7 are both bases. So what does that mean? If this piece is 5, what does that mean this little piece is? Well, 7 minus 5 is going to give me 2. So now we've got an angle. It's a 30, 60, 90 triangle. So the 60 is pointing here. We've got the short leg. And in a 30, 60, 90 triangle, the long leg, this height is going to be equal to the short leg multiplied by the square root of 2. Remember, that's what we practiced in class. So that's going to end up being 2 times the square root of 3. And I'm just going to leave it exactly like that. The height is 2 root 3. So now when we go to plug this information into the formula, area equals base 1, 5, plus base 2, 7, equals times the height, which is going to be 2 root 3, divided by 2. So you're going to type in 5 plus 7, that's 12, times 2, times the square root of 3. That gives me 41.569. It keeps going. We're going to divide by 2 and round at the very, very end. The area of this shape is going to be approximately 20.8. That's going to be meters squared. So we had to find the height using that 30, 60, 90 triangle, triangle that is a part of that trapezoid. Okay, and don't round it until the very, very end to keep our answers as precise as possible. Okay, what do I have on this picture? Well, I've got my 2 bases. I've got the full bases, but I'm missing my height. So again, I'm going to do what I did before. I'm going to copy that 8. This is a rectangle, so I'm going to copy that down to here. And so if that's the whole thing is 18, what is just this piece? That's going to be 10. So we can find our height using Pythagorean theorem. This is not a special right triangle, but it is a right triangle. So I get to do h squared plus 10 squared equals 11 squared. And so h squared is going to be equal to 11 squared minus 10 squared, which gives me 21. So h is going to be equal to the square root of 21. We're not going to round that. We're going to leave that as exact, and we're going to round at the very, very end. So now I plug that into my formula. That's going to be base 1, area equals base 1, plus base 2, times the height, which is the square root of 21, divided by 2. So 8 plus 18 is 26, times the square root of 21 is 119.14, and it keeps going. We're going to divide that by 2, and we're going to round at the very end. The area of this trapezoid is about 59.6 inches squared. So we're not rounding until the very end. All right, my last trapezoid problem. Let's see what we have and what we're missing. So we have, we do not have that base, but we do have part of this base. So if this part is 30, this is a rectangle. So what does that mean the top part is going to be? That top base is also going to be 30 inches, but we are missing this small piece. So in order to find this whole base, we need that small piece. But I do notice that this is a 30, 60, 90 triangle where this part is the 60, this part is the 30, and I have my hypotenuse. So how do I go from my hypotenuse to my short leg in a 30, 60, 90 triangle? I'm going to divide by 2. And so that gives me 6 for this piece. So that gives me an entire base of 36 inches because we did 30 plus 6. What is the height going to be? The height between those two bases? Well, that is the long leg of my 30, 60, 90 triangle. So how do I go from my short leg to my long leg? I'm going to multiply times the square root of 3. So my height of this will be 6 root 3. So this one's probably the most complicated one we've done so far. So when I do go to find my area, my bases are going to be 30 and 36. We multiply that by my height, which is 6 root 3. We divide that by 2. So 30 plus 36 is 66. We multiply that by 6 root 3. We get 685.8921198, and it keeps going. We divide that by 2. This is going to give me a big area of approximately 342.9 inches squared when I round that. Okay, so we did have bigger bases there, so it makes sense to have a larger area. My trapezoid was bigger. All right, so now let's go to our first kite problem. Remember that for the kite, we need our diagonals, so it's going to be diagonal 1 times diagonal 2 divided by 2. So I like to trace my diagonals. 3 and 3, we know that that's always true in a kite, even if it didn't have both of those marked as 3. Those short diagonals, the short diagonal is bisected. So 3 plus 3 gives me a diagonal of 6. And then 2 and 5 gives me a diagonal of 7 here on this one. So what we're going to do when we plug that in is that it's going to be area equals 6 times 7 divided by 2. 6 times 7 is 42, divided by 2 gives me an area of 21 meters squared. Okay? Exact same formula for a rhombus. Remember that in a rhombus, the diagonals do bisect each other, so the properties that we've already learned of these shapes are going to come into play. So if this piece is 25, that diagonal gets bisected, so this piece is also going to be 25. So what is that entire diagonal? That entire diagonal is going to be 50. This diagonal is 22. It gets that piece, so that piece is going to be 22 as well. So what is 22 and 22? 22 plus 22 is going to give me a diagonal of 44. And so the numbers that I plug in for my diagonals are going to be 44 times 50 divided by 2. So 44 times 50 is 2,200. That divided by 2 is going to give me an area of 1,100 feet squared of area in this rhombus. Okay? All right, our next problem, we have a rhombus. So again, same formula. We need our diagonals, diagonal 1, diagonal 2, we're putting them together and dividing by 2. Okay, so this is a 45, 45, 90 triangle. So if this is 4, what is this piece also going to be since that diagonal gets bisected? 4. It has a diagonal of 8. So since this is a 45, 45, 90 triangle, remember that the legs are going to be congruent. So if this leg is 4, this leg is also going to be 4. So those legs are both going to be 4 as well. So we have both diagonals are 8. Okay, so we're just going to plug that into my formula. Area equals, that's going to be 8 times 8 divided by 2. That is going to be 64 divided by 2, which is going to give me an area of 32 meters squared. So that's because that was a 45, 45, 90 triangle, which is why we reviewed our special right triangles before this unit. All right, let's trace our diagonals. Same thing, area equals D1 times D2 divided by 2. So let's trace our diagonals. This piece is 6. We know that the short diagonal gets bisected in a kite, so this is also 6. That makes that a diagonal of 12. In my other diagonal, I have 10, and this is pointing to the 6, so that's a diagonal of 16. So I'm going to plug those two pieces into my formula. Area equals 12 times 16 divided by 2. 12 times 16 is 192. That divided by 2 gives me an area of 96 feet squared inside of this kite. All right, now we have a rhombus. Again, area equals D1 times D2 divided by 2. Same thing as 1/2 D1 D2. And so I've got this piece of the diagonal is 4. So this piece will also be 4. So that is a diagonal of 8. Tricky thing here is we don't have this piece, but I do know that the diagonals are perpendicular, so I can use this right triangle that is on top of this shape to solve for x, which is going to be on both sides. And so I can use Pythagorean theorem, which is going to say that x squared plus 4 squared equals 6 squared. So x squared is going to be equal to 6 squared minus 4 squared. That gives me the square root of 20 for both of these little pieces, root 20, and this one's also going to be root 20. So root 20 plus root 20 is going to give me 2 root 20s. So whenever I go to plug that in for my diagonal, 2 root 20s is the total of what I have. So area is going to be equal to 8 times 2 root 20 divided by 2. So 8 times 2 times root 20 gives me 71.55, and it keeps going. And then we divide that by 2. We round at the very, very end. I have an approximate area of 35.8 meters squared. So I had 1 root 20 here, 1 root 20 here, so a total of 2 root 20s for when I added those together. All right, so that's 35.8 approximately. And then for this rhombus, we already have a full diagonal. That entire amount is 10. What they're wanting you to do here is draw in the other one. And so what is that diagonal? I don't know this piece, but I do know that these are perpendicular. So again, I'm going to use some Pythagorean theorem to find the missing piece, which is x. So x squared, this breaks down to 5 and 5 because I do need that smaller piece. So x squared plus 5 squared is going to be equal to my hypotenuse squared. And so x is going to be equal to 8 squared minus 5 squared is 39. So x is going to be equal to the square root of 39. If this is equal to the square root of 39, and then this is equal to the square root of 39, since those diagonals bisect, this is going to be 2 root 39s when I add those together. So when I go to plug this into my formula, area equals D1 times D2. That's going to be 10 times 2 root 39 divided by 2 should give me my area. And so when I do 10 times 2 root 39, I get 124.8996. I'm going to divide that by 2, round at the very end, and I get an area of about 62.4 inches squared. So that's all of our problems on trapezoids, rhombi, and kites, and we have our practices on the back, and we will check those tomorrow.